Corporate Finance Excel Practice Problem. Expected value, standard deviation, and coefficient of variation problem 1. Get ready. It's time to take your chance with Corporate Finance. We are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area, mainly on the right-hand side, although we do have some blue area down here as well. We're going to be projecting into the future and using some statistical type of analysis in order to help us with doing so. So we're going to imagine we have an advertising campaign that's going to be taking place. And once you get the concept of this, you can start to apply it to many types of things to try to get more of a systematic approach as you're projecting things out into the future. So we're going to say the possibilities, we're going to break those out into some possibilities and then assign probabilities to those possibilities. So we're going to say that we have a low outcome, average outcome, high outcome, or very high outcome. And then we're going to basically assign, in this case, what would happen in a quantitative measure at those different outcomes. In this case, we're talking about unit sales. So we're going to imagine we sell 650 units at the low outcome, 750, average, high, 900, and then very high at the 1,000. So once we have our probabilities, and note again, this is all estimates, of course, into the future. So if we're talking about our advertising campaigns, we would have to look into the past and think about what has happened in prior advertising, possibly get some averages from it, and possibly these are coming from our prior campaigns in terms of low, average, high, and very high. Then we could basically group our categories, and then we'd have to come up with probabilities. Now again, how would you possibly know what the probabilities are? You'd have to go to the past. It would depend on the type of data set that you're looking at. So you'd have to come up with the probabilities, possibly looking at past advertising campaigns, seeing what has happened then, and then thinking about the current scenario, the current economic situation, and then try to assign probabilities that you think the campaign will be average, low, high, or very high. And then we're going to calculate then our expected return here. So obviously the probabilities that we would have to assign would need to add up to 100%. So this could be a way for us to kind of break down our thinking into the future. It can be a little bit abstract when we think about into the future and we have nothing really to go on. It could be useful to break down our data based on past information and then estimates into the future into some kind of categories or range of ways that things could turn out, and then give our probabilities as to how likely those things might turn out. Again, as much as possible on past data, but of course taking into consideration changes in the future, and that could be a more systematic way for us to kind of think about what might happen. So if we take our totals here, we're going to say the 650 times the 20% then has a 130, the 750 times the 20%, the 900 times the 30%, and the 1,000 times the 300%. So then if we were to add those up, we get our total expected value, which would then be the 850. So we're going to say that basically our expected value then is going to be then the 850 in this case. Now, to break this down and show how we're kind of putting this into our statistical type of analysis, let's imagine then that these outcomes, let's put them into a series of numbers, a set of numbers that have 10 numbers to them, just so we could see how the statistical kind of analysis works in a normal number set. And then we'll do the same thing, applying it in a slightly different kind of way to calculate the standard deviation and the coefficient of variance. So let's imagine this data set over here. We're saying that 650 will be the outcome 20% of the time, 750 would be the outcome 20% of the time, 930 and 1,000 30% of the time. So let's just imagine then that we have the 10 outcomes that came out in that way. So in other words, I'm just going to have a list of numbers. I'm going to say that 650 equals the 650, and that's going to happen out of 10 times. It'll happen twice, 20% of the time. And then we're going to say that the 750 over here is going to happen twice. I'm going to say equals the one above it. That's going to be 20% of the time. And then the 900, we think out of 10 would happen 3 times. And then the 1,000, we're thinking out of 10, 30% would happen 3 times. So this set of 10 numbers then is kind of reflecting our probabilities here, right? We got the 20%, 2 out of 10, 20%, 2 out of 10, 3 out of 10, 30%, and 3 out of 10, the 30% for the very high. So if we take a look at that normal kind of data set of numbers, the natural thing to do then would be to say total, we'll total this thing up, equals the sum of this data set. That would then give us, if we underline that font, we're going to say the sum would be the 8,500. We can then take the mean or the average, which would be equal to the average, double-clicking the average, which would be all of these, or it would be the 8,500 divided by the number of items, the population, which was 10, and that would give us then the 850. I'm going to say equals and select the 850 above it, and then just simply autofill that down. So I'm going to put the same mean all the way down, the average number. Then we can look at the difference, right? The difference would be the 650 minus the 850. The difference here would be the 650 minus the 850 again. We have the 750 minus the 850. We have the 750 minus the 850. And now you can see we're doing basically our population variance formula over here, which would be each item minus the mean squared divided by the population. So now we're taking the subtraction point here, and then we'll square it in the outer column. So we're going to take the 900 minus the 850, the 900 minus the 850, the 900 minus the 850, the 1000 minus the 850, the 1000 minus the 850, and finally the 1000 minus the 850. Now we have these negative numbers and the positive, so now we're going to square them, which will make them all positive numbers and escalate the amount. So we're going to say this will equal then the 200 shift 6 caret and then 2. So to the second power, or the power of 2, or squared. I'm going to just copy that one down, and that should then have all the cells that would take the cell to the left and then to the power of 2. So now we have squared them. Let's then sum them up. So we'll go ahead and sum this up. And let's go and underline font and underline, and sum equals the sum of this data set, and that's going to give us the 175. Now, if we were then to take the population size, that's in this formula, and so I'm going to do the count. It's 10 because we had 10 of them, but let's do the trusty count formula because that's the cool way to get it. Count, and that's just going to count the number of items in these cells. So I'm going to select these 10, and there'll be 10 of them. And then we're going to go to the font group and underline, and then we want the population variance being the 175 divided by the 10. That's going to give us the 17.5 for the population variance, but it's squared, so typically we want then the standard deviation when we have our data set, which means we're going to take the square root, so equals the square root. So I'm going to select that item and pick up the 17.5. Square root of that would be the 132, adding some decimals, number group, a couple decimals there, and then we could take a look at the mean. So we'll pick up the mean down here, and that's going to be equal to, now what we calculate, well, it's calculated. This is the average, double clicking the average, selecting this data set. It's going to add them up and divide it by the number there, which would be 10, and there's the 850. We're going to then underline that, font group and underline, and then that's going to give us our coefficient of variation, which is going to be equal to the 132.29 divided by the 850. This number could be represented as a percent or decimal. We'll keep it at the decimal at this point. It's about the 16. Now note, we'll get into more detail when we do some comparisons about how to analyze these numbers. Some of them, like the coefficient of variation, will be more useful when we're comparing two different data sets. But just to get the standard process of calculating these, this is how we might do it on a standard data set. And this is how you could kind of think of this scenario broken out into a standard data set where you normally do your kind of statistical calculations. You can also do that here, right? If we can put our answers in a little key with the Excel formulas, or as many Excel formulas as possible. This would equal the average of these items And then we'd have the standard deviation, which could be the standard deviation. We're going to do the population size rather than the sample. So the standard deviation dot p, picking up this series of numbers again. That's going to then be the 132.29. Then the variance. So this equals the variance. Once again, the variance of the population dot p rather than the sample size. So we're going to go with the population for our purposes and select these again. And so there we have that. And then if we took just like the calculation down here, this would equal the standard deviation divided by the mean. And that would give us our percent, same percent over here if we add a couple more decimals on it. So that's going to be one way we can do it. Now, the way we'll typically see this then, when we break this out, however, is not to break it out in a series of 10 numbers, but I think that's a useful exercise to do. But we can then say, let's take our possibilities over here. So I'm going to pull in my same numbers, the 650. Going to copy that down. Let's do the autofill feature, copying that down to the 1000. Then we'll take a look at, this is going to be the expected value. Expected value. I lost the expected here. Let's say expected. We'll keep it just expected. And then I'm going to say this is going to be equal to one above it. And notice that's basically the average of the mean, right? And so we'll copy that down. And then the difference is going to be the 650 minus the 850, the 750 minus the 850, the 900 minus the 850, and then the 1000 minus the 850. And now we're going to square it the way we kind of did over here, right? Now we got our differences. Now we're going to square it. So let's say this is going to be equal to that number. I'm going to say shift 6, which is the caret, to 2 to square it. Copy that down using the autofill, and copy that down. So there we have that. And then we're going to basically add our probabilities at the end. So now we're going to add the probabilities after we have that squared amount, which will be the 20%, the 20, 20, 30, 30. So 20, 20, 30, 30. Let's take this whole 4 cells and make them a percent, go into the number group, percentifying them, and I'll copy this down so it picks up the 20, 20, 30, 30, 20, 20, 30, 30, and then we multiply this out, 40,000 times the 20%, and 10,000 times the 20%, and this equals 2,005 times the 30%, this equals the 22.5 times the 30%. That's going to give us our 6,750. Going to then underline that font group and underline, and our total, the total, will then be equal to the sum of these items. That'll give us our 17.5, and then we'll take the square root of that. So we'll take this square root, and that'll give us, well, let's just call it the standard deviation. Let's call it the standard deviation, which will be taking the square root, equals square root, selecting that item, square root of the 17.5. Notice, of course, this 17.5 basically matches where we were here. That's like the population variance, right? So I have the total here. We could label it, might be better called the population variance, the 17.5, and then we take the square root, and that's going to give us the expected value. So the expected value, or we're going to pick up the expected value, which is the average, which we calculated over here, or we calculated there. And then I'm going to underline that, font group and underline, and the coefficient of variance then. The coefficient of variance is going to be equal to the 132 divided by the 850, adding a few decimals here. We then get to our same 0.1556. Now, a lot of times when we see problems like this, note that if you have one type of scenario you're going to do, oftentimes we're looking for that basically expected value. And we might use that expected value as basically an estimate into the future. And then we might want basically to see the grouping around basically the average expected value, and the population variance could give us an idea of that. But if we have different kind of options that we're looking at, then that's often when the coefficient of variation will come into play. So we'll do a couple more and just recalculate these a few more times in some practice problems in this format so we get comfortable with these numbers, and then we'll work more about comparing different projects, focusing more on the coefficient of variation and how that could be like a practical thing to be using when we're making different types of projections into the future.